Hello, welcome to my channel, The Complete CSC Guide, and I am Sanskriti. So, in today's class, I am going to teach you about the unguided transmission medium. In previous classes, we have studied about the guided transmission medium. Now, in today's class, we will study about the unguided transmission medium, that is the transmission media, which is known as the wireless transmission medium. Okay, so this is obviously from computer networking, and we will start from the basic of our unguided transmission media. As I have already explained you, but still I will tell you that what is an unguided transmission media. Here what we are going to do, we are not taking any kind of cables or any kind of wires. Here, the whole transmission will be depending on air, which is the free space, right? So, we are calling it as a wireless media. Since wire is not present, it is known as wireless media, as well as it is unguided transmission media, since no guidance is provided in between the sender and the receiver. So, it is unguided. And what is the main thing? That is, no cables are there and no any kind of wires are present here. Here only the transmission media is the free space, that is your air, right? Now here you can see what is an unguided medium, right? So transmits the electromagnetic wave without using physical medium. Physical medium here is what? It's about your wires or your cable, or in case of fiber optics, the fiber optic. Okay, so no any kind of, this is mainly the transmission of electromagnetic wave is there, and no any kind of physical medium is being used here in this kind of transmission medium. That is it is wireless. That's why we are talking about the wireless media. Since no any kind of wire or any kind of fiber optics, nothing is being used here, only the electromagnetic waves are present, and we are talking about the air, which is wireless. Again, here air is the media through which electromagnetic energy can easily flow. So here the media is the basically the air, only the air. That's our free space. So the electromagnetic wave which is being transmitted, which is the main thing which is being transmitted from the sender to the receiver. And what is happening here? We are using the air as our transmission medium. So it is your wireless transmission media. If anyone tells you about the wireless transmission medium, then you can tell about this thing, unguided. Obviously unguided transmission media is the wireless transmission media. So any exam, if anything comes regarding wireless transmission media or unguided transmission media, both are same. Okay, so this is what is there. Now what are the different kinds of electromagnetic waves which are being used here? First is the radio wave and microwave and infrared radiation, and your infrared wave and your light wave. So here basically we have just distributed the whole thing, these electromagnetic waves, in some ranges, right? So how, in which range the particular kind of wave is going to function, that range have been distributed in some certain amounts, right? So here you can see 3 kilohertz. What is the range of your radio wave and your microwave? Is between 3 kilohertz and your 300 gigahertz. GHz, that is a gigahertz. So it is between this whatever the range is, that is for your radio wave and your microwave. So from radio wave to microwave, the whole range we are getting. What is the whole range for your radio wave and microwave? If you are working with the radio wave and microwave, then the range will be from 3 kilohertz to 300 gigahertz. That will be the whole range of the whatever we are working with the waves, that particular wave range. That is a radio wave and your microwave. Now the next one is your infrared. Okay, infrared wave, that is your 300 gigahertz to 400 terahertz. So this is the range for your infrared. Okay, so that is 300 gigahertz to 400 terahertz. So this is the whole range where the infrared wave is going to function, right? And the light wave, this one, that is your 400 terahertz to 900 terahertz. This portion is for the light wave. So basically you can see there's a spectrum type of thing which is being divided, and these ranges are that particular range where your particular wave can function. So we are distributing this whole range. Okay, so this is happening here. Now, first of all, as according to this, you can see that basically three kind of waves which we are talking about when we are going to study for our unguided medium, transmission medium. So first one is your radio wave, second is your microwave, and third one is your infrared wave. So these are the three kinds of wave which we are going to see in case of your wireless transmission media. These are the wireless transmission medias. So here we are mainly connecting with the electromagnetic waves, right? The main thing which is going to transmit here, that is your electromagnetic waves. So these are the basically the three kinds of waves. So first of all, we are going to study about the radio waves, right? So what are radio waves? You have already seen the range, that is 3 kilohertz to 300 gigahertz, but this is the whole range for radio wave and microwave. Now what is the range for only the radio wave? Let's see. So these are electromagnetic waves that are transmitted in all the directions of the free space. Radio waves, when you are transmitting the radio waves, they can transmit in all the directions, right? No specific direction have been settled for this kind of waves, that is your radio waves. They can go to all directions, right? So these are basically the electromagnetic waves which can be transmitted to all the directions, that is for your radio waves. These are omnidirectional, that is the signals are propagated in all directions. So these are omnidirectional in nature, since you can, if you want to transmit these kind of waves, you can easily transmit to all the directions. If it would have been unidirectional or bidirectional, they will be in one direction or two direction. But since it's an omnidirectional wave, so you can transmit this wave to all the directions wherever you want. Okay, so this is a kind of advantage for your radio waves. Now range, as I have already told you, this is the range for these two, radio waves and microwave. But in between these also some range is there which is only for the radio wave. What is that one? That is 3 kilohertz to 1 kilohertz. Okay, so this is the range of your radio wave, right? So this is for 3 kilohertz to 1 kilohertz, which is the range of your radio wave. Now here you can see, here the sending and receiving antenna are not aligned, that is the wave sent by the sending antenna can be received by and receiving antenna. So it is not aligned, that wherever you are sending something, so there are some antennas. Since we are working with the waves, so obviously some antennas will be there which are the sending antenna and your receiving antenna, right? So here there are two kinds of antenna, the sending and the receiving. So these are not aligned. This kind of, in case of your radio waves, the antennas are not aligned. What is the meaning of not aligned? That is, the waves seen by the sending antenna can be received by an receiving antenna. Okay, only sending, whatever thing is being sent, the receiving antenna will be getting that only. It can be sent in all the directions, but only a receiving antenna can get that one. Okay, and example is your FM radio. Whatever things you listen in your FM radio, that is a kind of radio wave. So whenever you are getting about something about your radio waves, you can easily understand that FM radio. So it is going to all the directions, right? So whenever if this radio wave comes, first of all, the main thing which comes in our mind, that is, it is omnidirectional. It can go to any direction. The range 3 kilohertz to 1 kilohertz, and the main thing is that it can be sent to all the directions, but it is not aligned. A sending antenna is going to send that one, and a receiving antenna is going to receive that one. That is your transmission wave. Okay, second is its applications. What are the applications of your radio waves? So first one is your FM radio, which is a very nice example, that radio waves and FM radio, you can easily just understand that one. And useful for multicasting, when there is one sender and many receivers. If one sender is there, that is your FM radio, that is your radio station. From there the signals have been sent, and that is being received by many receivers, right? So a particular signal, when it's sent by a sending antenna, it can be received by many, right? That is, it is multicasting in nature. Multicasting means one is sending and it is being, one is sending the waves and it is being received by many, right? So this kind of thing is known as multicasting. So these radio waves are multicasting in nature, right? So the examples are one sender and many receivers can be there in case of your radio waves. And here you can see the examples are FM radio. From one radio station, the signal is being sent and is being received by many receivers at the same time. Again, television is also there. You can understand that whatever thing is being transmitted, whatever thing is being broadcasted, everyone is getting that particular thing. So transmission is going from one station and it is being sender and it is being received by many receivers. Again, your cordless phones, same thing. If someone is calling you, it is being transmitted to many receivers. So from one whatever a telephone station or whatever thing you can say office, it's being transmitted and it can, the whole signal is being got by, received by many receivers. So one sender and many receivers can be there. So it's a multicasting in nature. Okay, now next is, what are the advantages of your this kind of radio waves? So mainly used for WAN, that is a wide area network, and mobile cellular phones. These kind of radio waves are being used. So wide area networks, that is your WAN, are being using this radio waves, and the mobile cellular phones, they are also using. Why they are using? Since it's multicasting in nature as well as it is omnidirectional in nature. So these are the two positive points due to which the WAN networks, that is your wide area networks, and the cellular mobile stations, that is mobile phones, are using these ones. It covers a large area and they can penetrate walls also. It is also big advantage of your this kind of radio waves. What is the thing? That is your, it can cover a large area, right? So it is about a large area. So obviously WAN connection, we have studied about, it's about a large area. So obviously apart from your building boundary, so obviously they can use this kind of radio waves, as well as what is the advantage? It can penetrate the walls also. It's a huge advantage of this radio waves. If there is a wall, it can penetrate that wall and it can be transmitted easily. So this kind of thing is being used in FM radio as well as your telephone, as well as your television also, right? And it provides a high transmission rate. It's also a huge advantage. It's providing a high transmission rate. So these are the very important points, which is the advantages of your radio waves. And due to this is the main functions, the whole things, the main functions for your radio waves are also many in number. That is your television, your radio, and as well as your cordless phone. So this is the main thing about your radio waves. It's a very important or your main kind of wave. You can understand that in our day-to-day life we can easily understand this one, right? So this is basically what is about your radio waves. It's omnidirectional, it can penetrate the walls, it have a high transmission rate, as well as many advantages are there. It can cover a large area also, and used in FM radio, television, and your mobile cellular networks, as well as your WAN networks. Done. So this is what is about your whole radio waves. Now the next wave, that is your microwaves. So microwaves are, now what is the range? 1 kilohertz to 300 gigahertz. Then since it is for your radio waves, now 1 kilohertz to 300 gigahertz, that is your range of your microwaves. Now what is about microwaves? Microwaves have two kinds of microwaves are there. Two basic kinds of microwaves are there. That is, first one is the terrestrial microwave and second one is the satellite microwave. So terrestrial means about the land and satellite means your up above, right? So terrestrial microwave, technology that transmits the focused beam of a radio signal from one ground based microwave transmission antenna to another. So here what is happening? This is transmitting the focused beam of a radio signal. So focused beam means what? whatever the radio signal is being transmitted, that is focused, that is going to a particular direction or particular receiver. So it is focused in nature, right? So whenever this kind of some focused wave is beam of radio signal is being transmitted from one ground based microwave transmission antenna to another. Here, as I have already told you, it is about the terrestrial, that means from one ground antenna to another grounded antenna, microwave antenna, that is sending the signal, and the signal is focused radio wave signal which is going to the another signal, that is a receiving signal. So obviously here what is the main thing? It is about the terrestrial antennas which are being fixed on ground. One terrestrial antenna which is fixed on one portion of the ground, and another is on another portion of your ground. So it is being fixed on the ground. That's why we are calling it as the terrestrial microwave, right? So this is basically what is happening. The microwave are being transmitted from the sender to the receiver, and it is focused radio signal beams of focused radio signal, right? And the frequency ranges from 1 gigahertz to 1000 gigahertz. Its main ranges, that is terrestrial microwave ranges 1 gigahertz to 1000 gigahertz. For terrestrial microwaves, it is 1 gigahertz to 1000 gigahertz, right? Now, what is their unidirectional? Now, it is of unidirectional in nature. It is unidirectional. That was omnidirectional. What was that? That is your radio waves. It can go to any direction. This is unidirectional in nature. It can go to only one direction. You cannot transmit it into many directions. So one direction only, unidirectional in nature. That is, sending and receiving antenna is to be aligned. That is, the waves sent by the sending antenna and narrowly focused. Whatever thing is being sent by this sending antenna, and this is the receiving antenna, right? So this is sending and this is receiving antenna. So whatever thing is being sent is being focused to this. So this one is for focused beam or your focused wave, that is being focused from the sender to the sending antenna to your receiving antenna. The beam should be focused since it is unidirectional in nature. It cannot be transmitted in many directions. So, okay, so many antenna, so many receivers are there. It can be received by many receivers. No, it should be focused since it is unidirectional in nature, right? So, it is unidirectional in nature. Now, antennas are mounted, and one thing, it is narrowly focused. Narrowly focused means whatever things just it is being narrowly focused to the same antenna where the receiving antenna is there. So from the sender, whatever thing is transmitted, your wave is transmitted, that is being sent to the receiver, and it is narrowly focused, right? Now, antennas are mounted on the towers to send a beam to another antenna which is kilometers away. Here the antennas can be mounted on the towers. Why on the towers? So that they can easily be transmitted to your receiving antenna. So these antennas are mounted on the towers to send a beam to another antenna which is kilometers away. If your antennas are kilometers away, they are apart from each other, kilometers apart from each other, then also this kind of transmission can be possible because they are mounted on the top of the towers, so that whatever transmission is going on, if your antennas are kilometers away from each other, they are so much apart from each other, then also your transmission can easily take place. So these antennas, these are terrestrial antennas. It has been mounted on the ground, but these are mounted on top of the towers so that the transmission can easily take place, right? So no hampers comes in between those towers. So these are mounted on the top of your towers. It works on line of sight transmission. This is the main thing. This basically works on the line of sight transmission. That is, the antennas mounted on the towers are at the direct sight of each other. Line of sight means they are in the same direction. That is, directly they are on the same side. That is your direct sight to each other. They should be direct in sight of each other. The line of transmission should be same. Here one antenna is there, and here the line should be same. Okay, so they should be in direct sight of each other. Directly they should be in sight of each other. Here you can see the example, that the whole diagram, that is, here it's the earth on which the thing is mounted. Your antennas are mounted. Since it is terrestrial in nature, these antennas are mounted, transmit antenna and your receiving antenna, and the signal is being propagated. So you can see that here this thing is line of sight, means the same, directly they are in sight of each other, right? So you can see here in the example also, which is the diagram. So this signal propagation, they are using the line of sight, because the transmission is only unidirectional in nature. We have to take care that the transmission should take place in an easy and efficient way. So that should be in line of sight nature, that the sending antenna and your receiving antenna, that is the transmitting antenna and your receiving antenna, and the main thing, the whole beam or the whole wave which is coming, that is narrowly focused, so that it can easily go to the receiving antenna. So this is all about your terrestrial microwave. The antennas are being mounted on the ground, the transmitting antenna as well as your receiving antenna. That is why we are calling it as the terrestrial thing, okay, terrestrial microwave. And the main thing is there, since it is unidirectional in nature, so to just protect it from any kind of hindrance, we are mounting the antennas on top of the towers, so that the transmission can easily take place, and line of sight transmission is being conducted here. Now, what are the characteristics of your terrestrial microwave? That is, frequency range is 4 to 6 gigahertz to 21 to 23 gigahertz. That is your frequency range. The frequency range is from 4 to 6 gigahertz and 21 to 23 to 21 to 23 gigahertz. This is the frequency range of your terrestrial microwave. Now, bandwidth is from 1 to 10 Mbps. The bandwidth which is of this kind of terrestrial microwave, that is from 1 to 10 Mbps. Okay. And the short distance, it is of your short distance. That radio waves, what we have understand, that is for a larger distance, larger area can be taken. That's why we were using it in the WAN network, that is your wide area network. But this kind of terrestrial microwave, as you can understand from the definition itself, that this should be in the line of sight and they should be in sight of each other, direct sight of each other. So obviously this can be done in a small area. It cannot be done in a larger area. So it can only take place in a smaller area, not in a larger area, right? So short distance, inexpensive for short distance. It is inexpensive since it's for a short distance, right? If you are going to use for a larger distance, maybe it will be expensive, but it's not possible. It's only used for a shorter distance only, and obviously that will be inexpensive. Now next is for longer distance. When it is used, it is basically good when we are using for the shorter distance. But if you are using it for a longer distance, then expensive for the longer distance and needs higher tower for it. Since you can understand that line of sight is present here, so obviously you have to take care that the particular tower should be mounted in such a way that the transmission can easily take place without any hindrance. Where it is for shorter distance, you can easily do that one, right? But obviously that will be inexpensive and that will be okay. But if you are going to use this kind of thing for a longer distance, then what will be the thing? It will be more expensive. Why more expensive? Since it needs higher tower for it. Obviously the distance is, when the distance is small, then you can easily mount two towers and easily the thing can take place. But if it is for a larger distance, maybe some more buildings comes in between, or maybe some kind of hindrance comes in between. So obviously the tower should be more higher so that the transmission can easily take place. So it is very expensive when you are using for a longer distance. So basically it is perfect for a shorter distance only, right? And the attenuation, that is the loss of signal, It is affected by environmental conditions and antenna size. Obviously, you can understand that whenever it is mounted and the transmission is taking place, the main thing, loss of signal, it is very much, it comes here for this kind of microwaves, that is your terrestrial microwave. Why it is coming? Since loss of signals will be affected, the signals will be affected by the environment, environmental factors, maybe it's rain, storm, anything that will obviously affect your signals. That is, loss of signal is very much possible in this kind of thing. It is the whole signal, the whatever is transmitted in between, it is heavily affected by the environment, as well as it is also affected by the antenna size. What kind of size of the antenna you are using, your signals will be very much affected by this kind of thing, that is your environment as well as the antenna size. Whatever the size of the antenna, the signals will be very much affected according to that. So basically these are the disadvantages of your terrestrial microwave. It is very much good for whenever you are using for a shorter distance, but for a longer distance it will be expensive. That is your disadvantage. And it is being affected, highly affected by environmental factors and the antenna size. So you have to see where you are mounting the antennas. You have to very much take care of that distance as well as that height. So these are the disadvantage of your terrestrial microwave. Now, advantages are what? Cheaper than using cables. Obviously, whatever price you are paying for using the cables, different cables, right, or the fiber optics, so it is taking a huge amount. But it is lesser than that, since here the main media is your ear. The only thing which is being expensive, that is the antennas whatever you are using. But for a shorter distance, obviously it is cheaper than using long cables. So here the air you are using and obviously the antennas. So shorter distance it is very much beneficial. Longer distance, again this is also expensive, right? So obviously for mainly it is the advantage when you are using for a shorter distance. But if a longer distance is the disadvantage, you are not getting. So now, does not need land for installation of cables. So for installation of cables, nothing is needed, right? Here you are just installing the antennas only, and the signals are propagating in between, but no any kind of installation is needed, since the cables are not there. So you have to plug in the cables, you have to install the different cables or the wirings. This is not needed here. So obviously this is a advantage for this kind of terrestrial microwaves, right? And next is easy communication in terrains which is hard for others. In terrain areas, you can easy communication can be take place by this kind of terrestrial microwaves, since there no any kind of cables can be used. So this kind of thing can easily be used there, and the communication can easily take place in terrain areas, right? So there, these cables, wires, these are not possible to be used. So these kind of microwaves can easily be used in that kind of area. So it's a huge advantage for this kind of thing. Now, communication over oceans can be achieved also. Over oceans, these kind of communications can be achieved. Obviously that will be expensive, but this kind of communication can be achieved over oceans also. So since here the antenna is directly being connected, no any kinds of wires are being used, only the terrestrial antennas are used. So obviously over oceans this kind of communication also can be used. So it is also huge advantage for your terrestrial microwave. Obviously these two kind of advantages are obviously very much useful for this kind of terrestrial microwave. Now, disadvantages: eavesdropping, and your signal, obviously your signal is also affected, and eavesdropping can also happen in this kind of thing. Now, out of phase signal can be out of phase also, since your environment factors is there, your antennas size can affect. So obviously signals can be your this out of phase in this kind of. So this is a kind of disadvantage obviously in this kind of thing, right? Now, susceptible to weather conditions, that I have already told you: rain, storm, any kind of a thing. If some heavy air is going on, that can also affect your signal. So this is the basically huge disadvantage, and it cannot be trusted, since if a storm comes, or if any kind of rain is happening, or any kind of environmental factors can easily affect this kind of signals. The signal, whatever the your signal strength is there, that can be easily affected. So environmental factors can easily affect your signals. So susceptible to weather conditions. If your weather condition is good, it is sunny day, everything is good, then you can get a good signal, but the signal can be transmitted easily. But if the signals will be weak if your environmental conditions are not proper. So it is susceptible to your weather condition. Weather changes and your signal also changes, right? And bandwidth is limited bandwidth is given. In that particular limited bandwidth, your signals have to be transmitted. So this is what is there in your terrestrial microwave, right? You have to main things which you have to keep in mind, that is, it is being mounted on the land, that is why it's terrestrial in nature. And the main thing is it is unidirectional, and the whole beam which is being sent from the sender to the receiver, the transmitted beam should be narrowly focused so that it can easily be transmitted. But it is highly affected by your weather conditions and your antenna size. The antenna should be mounted on top of the towers so that the transmission can easily take place, and it should be in a shorter, it can be in a longer distance also, but for a shorter distance when you are using this thing, it is obviously helpful as well as you are getting some advantages. But if you are getting it for a longer distance, then disadvantage will be there. It will be expensive in nature, as well as many kind of transmission loss will be there, that is your signal loss will be there. So this is the main idea about your terrestrial microwaves. Now next is your satellite microwave, right, where we are talking about the free space. It is about the space. Now, physical object that revolves around the earth at a known height. Here we are talking about the satellite. So what is there? That is some physical object that revolves around the earth at a known height. We know at what height the satellite is being released and at what height the satellite is there from the earth. So it's a physical object at a known height, right? So this is what is about your satellite. Now, more reliable as it offers more flexibility than cable and fiber optics. It is reliable than your cable and your fiber optics. So it can be used in case of your cables and fiber optics, since it is very much reliable, right? And we can communicate with any point on the globe. Since it is being used by the satellites, you can communicate to any point around the globe, that is on your earth. Any point on your earth you can easily communicate, since the whole communication is being taken by this satellites. So obviously you can communicate in any portion of your globe, that is your earth, right? So communication is taking a very broad range. Now the area is going to be very broad, since over the whole earth you are talking about, right? Now satellite accepts the signal transmitted from earth station at it, and it amplifies the signal. Amplified signal is retransmitted to another station. Now what is happening here? The satellite accepts the signal transmitted from earth station. First of all, from the earth, the signal is being from any point on the earth. Suppose this is the earth. From any point on the earth, the signal is being transmitted, and here some satellite is there, right? So and here some point is there on the earth where it is. So first of all, what thing is going to be there? That is the sender and the receiver. So what is happening? First of all, the sender is sending what the whole thing, that is the transmit signal is being transmitted, and whatever signal is being transmitted, it is being amplified here, right? The satellite, what it is doing, it is amplifying the whole signal. Then what it is doing, it is just sending that amplified signal to the receivers. That amplified signal, right, is going to the receiver. So sender is sending the signal, transmitting the signal from any earth station. The sender is sending the transmitting the signal. It is going to the satellite. The satellite is amplifying the signal. then that amplified signal is again transmitted to any portion where on the earth the receiver antenna is there. So here what is happening, the satellite is accepting the signal transmitted from earth station, it amplifies the signal. Okay, what is happening, amplified signal is retransmitted to another station. So here basically the work of the satellite is to amplify the signal. Whatever signal is being sent, you can hear what is happening in terrestrial microwave. The microwave is being used here, but we are taking advantage of the microwave for a certain distance, for a shorter distance. Here what is happening, whatever station is there on the earth, it is sending the signal to the satellite. The satellite is amplifying that particular signal and sending that signal back to the earth, but to that portion where you want, where the station is there, to another station. So here the range is very big. Here you can use the whole globe. You can send anything. You can communicate in any part of your earth. Whatever thing you want to send, you just send the signal to the satellite, and the satellite will amplify your signal and send to that particular portion. It will communicate your signal to that particular portion on the earth where you want, and an amplified signal will be sent there, right? So here a huge advantage, as you can have the distance about the whole earth, right? So this is the main advantage of your satellite microwave. You are using the microwave here also, but your range is very big now, right? Now you can see here that first earth station, it is sending an uplink to the satellite, and second earth station is getting the downlink. Now advantages, more coverage area than terrestrial. Obviously not only more, it's a huge coverage area than your terrestrial one. In terrestrial one also we can use it for a longer distance, but how much longer? If you are going to use it for a very long distance, then obviously your price will be expensive also, and maybe the whole atmospheric nature, whatever environmental factors, that will affect your particular signal. But here the area is huge area, the whole earth you can cover, so area is huge area than your terrestrial one. So obviously it's a huge advantage over the terrestrial microwave, right? And transmission cost is independent of coverage area. Your transmission cost is not depending on your coverage area. Whatever coverage area, the transmission cost will be not affected by your coverage area. You can use the whole coverage area, right? The coverage area will be more, but your rate will be not the whatever, it will not be expensive depending on the coverage area. That was on the case of your terrestrial microwave. If you are using for a shorter distance, it will be inexpensive. If you are using for a longer distance, it will be expensive, but it is not dependent on your coverage area. It is independent of your coverage area. Whatever rate will be there, it will be not dependent, right? Now disadvantage, okay, used in mobile and wireless communication applications. It is used in mobile communication, whatever we are using day to day in our mobile phones. So in mobile phones, whatever things we are using, that is by our this satellite communication, that is the satellite microwaves. So you can now easily understand how the working is going on, how the signal is being sent, it is amplified, and we are getting the signal back. So this is used in your mobile and wireless communication. Now easy to install, it is very easy to install. The satellite is being there, and you have just to send your signal and getting the signal. So the installation is not so much complicated, so much wires, so many things, so antennas should be on the top of the tower. No such things are there, right? So here the installation problem is also solved now. And weather forecasting, the examples are for weather forecasting. I think you have already heard that for weather forecasting some satellites have been sent by ISRO that can easily get the perfect weather forecasting, whatever thing is being done now for this today's weather, that what kind of your rains or what kind of things, storms are going to come. So these are being updated in day-to-day nature. So these kind of satellites are being used for getting this weather forecasting newses, right? And your radio or TV signals are also using this kind of microwaves. for broadcasting and your mobile communication. So these kind of things are using your satellite microwave. And the disadvantage is satellite design and development needs more time. Here is one disadvantage for the satellite communication. The designing of the satellite, right, the designing and the satellite and the development of the satellite, how you have to design, what kind of purpose it's going to solve, right? So designing the satellite as well as the development of the satellite, it is taking very much time. So much time is needed. Obviously you can just make a satellite and you're throwing the satellite. No, you have to design. First of all, you have to think what kind of purpose it is solving, whether it's for a weather forecasting in nature, whether it's for the mobile communication. So obviously the designing will depend on that one also. So first of all, you have to see the purpose, you have to design the whole satellite, and you have to develop that one. So this will take a huge time. Obviously huge money will be also needed for this kind of thing. So high cost is there. Whenever you are going to make the satellite and they're making the satellite, they are sending the satellite to put the satellite on a perfect point and to design, develop, everything is there. So time is needed, very much time you have to spend on that one, as well as you have to spend so much money on that one also. So cost as well as time, both things are there. Now satellite needs to be controlled and monitored on regular periods so that satellite remains in orbit. This is also a problem. The satellite, when you are sending, right, so it is rotating on an orbit. So you have to maintain that on a regular basis. You have to check whether your satellite is orbiting on the same orbit, it's perfectly working or not. So regularly you have to check that one on a particular period basis. You have to check that yes, the satellite is perfectly working or not, or it is going through the orbit, it's perfectly rotating or not. So you have to control that one, you have to check that one, you have to make a check in every period, every particular period. So this is also needing some amount. This is also have some cost to maintain that one. Designing and development is there, then maintenance is also there. So these things are the disadvantage of your satellite microwave. But obviously the advantages is more, so it is basically it is used in these particular purposes, right? Now this is the whole thing about your microwaves. Microwaves are two kinds, terrestrial and your satellite one. Terrestrial is for mounting on the ground and satellite is for the space. That is, your satellite is mounted and that particular physical object is getting you some signals. You are sending the signal to that particular satellite, it's amplifying and it's sending back to the earth. You can use the whole earth for communication purpose. Wherever you want to communicate your signal, you can easily communicate. But in terrestrial, this kind of feature is not given. It is for a shorter distance only. You can use it for a longer distance, but it will be expensive. Here the range will not depend on the coverage area, but the dependence is what? The satellite designing, the satellite development, and the satellite maintenance. These are the three areas where you have to spend some money. Otherwise it is very much efficient, as well as it is, you can it is very much advantageous than your terrestrial one. Then now the next one is your infrared wave. Infrared wave is, the range is from what, 300 gigahertz to 400 terahertz. So this is the range. So wireless technology used for communication over shorter range. Again here it is for the shorter ranges. Your radio wave was for a longer distance, a longer range, and your that satellite microwave, that was for a longer distance. But here infrared radiation is for, infrared waves are for a shorter distance only, that is for a shorter range. Okay, now frequency is from 300 gigahertz to 400 terahertz. This is the frequency range. Data transfer between two cell phones, TV remote operation. Okay, now it is very much shorter distance. Now, since here data transfer between two cell phones, whatever the data is being transmitted, that and your TV and your remote. Whenever you are using the remote, you can see a particular light on the top of your remote. You will see a particular light which is blinking whenever you are pressing any switch from your remote. Okay, so some kind of light is blinking on that one, and you can see that a particular light also on your set-top box, or on your TV console, right? There you can see on your television some light is blinking. Or whenever you are using the Tata Sky or any other thing about your set-top box, there also you can see whenever you are pressing any button on your remote, a particular light is blinking on your remote, as well as a particular light is blinking on the set-top box or on your television. Whenever you are using the television remote for switching any kind of switch you are using, you will see that particular light is blinking here, and that particular light is also some light is also blinking on your television portion, your console portion where the whole television is there. Or you can see the set-top box. Whenever you are taking the remote of your set-top box, you are pressing any switch on your set-top box, you will see that on the remote some kind of light is blinking, and your set-top box there is a light that is also blinking. So this is the what is happening here. When you can do one experiment. You just put something on that portion on in front of the set-top box, and you try to use the remote. You will see no function will happen, right? If you are going to change the channel, or you are going to just function on the sound of your television, you will see that if any kind of hamper is been between that your remote button and remote light and that particular light which is there on your set-top box, you will see that no function will be generated. Why this is happening? This range, this is smaller range, this ray, whatever ray is going there, that is your infrared wave. This particular wave is your infrared wave. From your remote to the television, this connection, you are not seeing any kind of connection, you are just switch on the TV, you will see this kind of radiation is there. You cannot see the radiation, but the function is going on. If you will keep some hindrance in front of that, keep some kind of copy or something, some kind of thing in front of your that set-top box or your television, you will see that your remote is not working. Why it is not working? Since the radiation, there is some hamper is coming in between, that some hindrance is coming in between that particular radio wave, and the function is cut off. So no function will be generated, so your TV remote will not work at that time. So this is the what is the thing, that is your infrared wave. So here the operation is for between two cell phones and your TV remote operation. Done. So this is what is happening in your set-top box or your TV remote operation. Now, characteristics. What are the characteristics? It supports high bandwidth. This kind of infrared waves, they are supporting high bandwidth, right? And hence the data rate will be high, very high. Obviously, when the bandwidth is high, the data rate will obviously be high. So in infrared radiation, infrared wave, what is happening? The radiation, that is your bandwidth, will be high, and the range, that is the price, will also be over cost, that is very high. Data rate will be very high. Infrared waves cannot penetrate the walls. As I have told you about the experiment, that it cannot penetrate the walls. Whenever you are using the button of your TV remote, some radiation is going on, and this is the set-top box where the radiation is connecting, and obviously the function is going on. But if you keep anything in front of, suppose any kind of hindrance is created in front of that particular radiation, then that function will not take place. So what we know from this, that it cannot penetrate the wall in the sense it cannot penetrate any kind of hindrance. So this is the experiment which you can do and understand very easily, that it cannot penetrate the walls, right? Now the infrared communication is in one room cannot be interrupted by the nearby rooms. If some kind of infrared radiation is going on in one room, it cannot be affected by another infrared radiation in another room. Obviously, if you are using the remote in one room, it cannot be affected by anything from the another room. So this is the advantage, right? Nearby rooms, whatever infrared radiations are being used, in infrared waves are being used, if some TV connection is there in this room and some TV connection is there in another room, so if you are using a remote for this connection, there someone, another person is using another TV remote for another car, so no hindrance is being created. So this kind of thing is one advantage, right? Now, and infrared communication provides better security and minimum interference. Obviously, it is better security, but minimum interference is there. If this small distance, very much a small distance, so minimum interference is there, as well as it is providing you a better security also. Infrared communication is unreliable outside the building because the sun rays will interfere with the, sun rays will obviously interfere with your infrared waves, right? This is the thing. Infrared radio waves will be affected by the sun rays. So obviously, if it is unreliable, it's very much reliable when it's inside your building, you are using it, minimum interference is there, it is not hindered by anything outside. In another room, if you are using it within a room, it is not affected by anything in another room. But it is unreliable, it is very much affected, it is if you are going outside your building, that is in the environment, it will be affected by the sun rays. You know about the infrared radiation, so obviously it will be affected in that case. So infrared communication is unreliable outside the building. Inside the building, it's very much protected, you have the security purposes, it is not being hindered by anything, less interference is there. But outside the building, why? Because the sun rays will interfere with the infrared waves. So this is the basically the disadvantage of your infrared radiation, infrared waves, that is the radiation, the sun's radiation, infrared radiation will obviously affect your infrared waves. So you cannot use it outside your building. Whenever it's used, it is within the building. So this is what is in your infrared waves, right? So let's have a quick recap whatever we have studied. So unguided medium, now you can easily have the idea about unguided media. What is that? That it is about the electromagnetic waves. So we are using the electromagnetic waves, basically three kinds of waves: the radio wave, the microwave, and the infrared waves. So these are the waves and the range: radio wave 3 kilohertz to 1 kilohertz, microwave 1 kilohertz 300 gigahertz, infrared 300 gigahertz to 400 terahertz, and light wave is for about 900 terahertz, that is above. Now radio waves, what we have studied, they are transmitted to all the direction, that is omnidirectional in nature, and it is being frequency 300 kilohertz to 1 kilohertz. Here sending and receiving antenna are not aligned, right? They are not aligned. One sender can be there and many receivers can be there. One sender antenna is sending and it is being received by many antennas. So example will be what? Radio waves, that is for your radio transmission, whatever signals have been saying, that is the FM radio, right? And here what is happening, the signals are being, okay, the antennas are not aligned in case of this. The application is for multicasting. This is multicasting in nature, one receiver and one sender and many receivers. Example, FM radio, television, and cordless phones. Okay, advantage was what? It is for WAN, used for WAN and your cellular mobile phones, right? Since one sender and many receiver, again it is covering a large area, a huge area is being covered, and they can penetrate walls. Obviously you will, every time you have to remember that radio waves was the only wave which was it can penetrate the walls also, right? And provide high transmission rate. The transmission rate here will be high. Again, microwave, two kind of microwaves was there: terrestrial microwave and your satellite microwave. In terrestrial microwave, they were mounted on the ground. The sending antenna, that is the transmitting antenna, and your receiving antenna, both were mounted on the ground, and the transmission was unidirectional. Obviously the beam of focus, that was the radio signals, beam of radio signal, that should be focused, that should be narrowly focused so that the transmission can easily take place. And the whatever antennas, the sender or the receiver, that should be mounted on top of the tower so that the transmission can easily take place, right? Frequency range was from 1 gigahertz to 1000 gigahertz, right? And it was unidirectional in nature. The sending receiver antenna should be, and the receiving antenna, they are not aligned. Antennas are mounted on the towers so that the beam to another antenna which is kilometers away, they can easily be sent, right? And this it was working on the uh, principle of line of transmission. They should be on the same line of transmission, site of same site, right, to each other, direct site of each other, the and sending antenna and the receiving antenna should be there. Okay, so focused, narrowly focused beam should be sent. And here the characteristic was for frequency range 4 to 6 gigahertz and 21 to 23 gigahertz. Done. Now bandwidth 1 to 10 mbps, and short distance, it was for inexpensive for your shorter distance and expensive for your larger distance, right? Why expensive for larger distance? Since you have to keep a higher tower range for the antennas. You have to put the antennas on a higher towers. Again, what was there? The attenuation, that is loss of signal. It was affected by environmental changes, very much affected by environmental changes, and also the antenna size. Then advantage, cheaper than cables. It was obviously cheaper than cables, does not need land for installation of cables, and easy communication in terrain areas as well as communication over oceans can be taken. So this was the best advantage, that is for the terrain area and your over the oceans. This kind of communication can easily be processed in terrain areas as well as the oceans, over the oceans. Now disadvantage, eavesdropping, out of phase signal, susceptible to weather conditions, and bandwidth was very limited for terrestrial microwaves. Then satellite microwave, what was their physical object that is revolving around the earth, right? So this was at a known height, that is your satellite. And what is there? More reliable, that is offers more flexibility than cable as well as your fiber optics. Then, and what was there? We can communicate with any point on the globe. The main advantage for your satellite microwave communication was that you can communicate over a huge distance, and terrestrial for a shorter distance, right? So satellite accepts signal. What was happening there? The in your terrestrial, the signal, the transmitting station and the transmitting antenna was transmitting and the receiver antenna was receiving. But in here satellite communication, what is happening? The transmitting station, it is sending the signal to the satellite. The satellite is, what it is doing? It is amplifying the signal and it is sending back to any point where you want on the globe. The receiving the station is receiving that signal. So obviously the area is huge. Now this kind of thing is going on, that is uplink is there and downlink is there. This satellite is working on first station and second station. Now it was having a more coverage area than terrestrial one. Transmission cost is independent on coverage area. It was dependent, transmission cost was dependent on coverage area for the terrestrial one. If shorter distance, short on is what it was inexpensive, and for longer distance it was expensive. But here nothing is happening like that. Here that whatever that cost is independent on the coverage area, right? And used for mobile and wireless communication applications, right? Easy to install, it's very much easy to install. Weather forecasting, it's used for weather forecasting. You have listened about the different satellites being processed for weather forecasting purpose. It was used in radio or TV signals. It was broadcasting and for mobile communication. Now disadvantage, satellite designing and satellite development. These two things wants huge time as well as huge money. So this was the very much huge disadvantage for your satellite microwave. And obviously the satellites should be controlled in a regular period, right, in a regular manner, so that whatever thing is going on, the satellite is revolving, it should be checked that is revolving perfectly, as well as it should be checked that it is working perfectly, revolving on the orbit, it is perfectly revolving around the orbit, and it is perfectly working. So these three things are very much needing time as well as needing money. Whenever you are going to check it at a particular period, obviously it will also need some money. So the designing, development, maintenance, everything needs huge time and money. So these are the disadvantage of your satellite microwave. Otherwise your satellite microwave is very much more advantageous than the other things, since you are getting a amplified signal. The main thing, you are getting an amplified signal in nature. So obviously the whole earth you can use. So this kind of huge area is not being given by any kind of waves, right? Only the satellite microwave is providing you a huge area to communicate. Obviously it is the better one, but if you are getting the better one, you have to pay some time as well as pay some money. A huge time and money is needed for this kind of purpose, right? So this is the basically the disadvantage. And the infrared waves, it was also a wireless communication and over shorter ranges, and the range was 300 gigahertz to 400 terahertz, and the data transfer was between two cell phones and your TV and your remote. I have told you about the experiment, how you can see that how the infrared waves is generated and how they are working. So obviously it supports high bandwidth, data rate will be high, infrared wave cannot penetrate the walls, okay, and the infrared communication in one room cannot be interrupted by the infrared radiation in another room. And infrared communication provides better security and minimum interference. It is good when you are using inside the building. It will be hampered if you are using outside the building. By whom? By the sun. Sun will affect your infrared waves when it is outside the building. So this is what is there in your unguided transmission media, that is your wireless transmission media. Many of you have also requested for this particular chapter. I hope that you have understood well these all things. This is the whole portion what is there in your unguided transmission media, that is a wireless transmission media. If you have understood, then it's okay. If you have any kind of question, you can ask me in the comment section. And if you have any other topic you want me to tell you about, then you can tell that also in the comment section. If you like my channel, then please give a like, please subscribe my channel so that we can study more together. And I hope that whatever knowledge I am giving you, you will be getting some help from that thing. It will be helpful for you, right? So till then, take care and goodbye.